Hi, my name's Joe Onisick, and I'm here today to talk about application-centric infrastructure, or ACI. When we're talking about ACI, we're talking about the data center and the deployment of applications within that data center. The sole purpose of the data center itself is to publish those applications and provide the applications which are driving our business or our mission forward. When you look at the way applications are deployed today, they've changed rapidly over the last 30 years. They've moved from single-tier, single-server applications to multi-tier, multi-server applications. They've moved to cloud deployment models, and we're moving into more and more big data models that are using our networks in a very different fashion. At the same time those 30 years of rapid application change have happened, our network itself has stayed very static. We're still using the same protocols we started with on the network side. We're using IP and spanning tree protocol and all the same things we started with, but having to change the way in which we utilize those to be able to support the rapidly changing needs of the application. In order to do that, to leave the network as static as we have while the application changed, we've ended up building in an accidental layer of complexity that rides above the network and below the application. This complexity exists in any given data center environment. And what it does is cause us to be slower to change and adapt to new applications and new business demands. This complexity is what slows down the way in which we can deploy those new apps, get the network up to speed, and get the layer 4 through 7 services required by that network up to speed. Now, there are several technologies emerging in our industry today, and most of them revolve around the concept of software-defined networking, or SDN. And with these technologies, what we're getting is a movement of that complexity and some centralization of management and automation, but we're not really changing the underlying problem. What we end up doing is basically treating symptoms rather than curing a disease. So if you take OpenFlow as an example, what OpenFlow does is give me a centralized controller for the configuration of the network itself. So I'm really just taking that complexity and I'm moving it out to a centralized point. And now what I'm able to do is centralize the way in which I program routes within the network and do that based on standard IP information, but I'm still not really getting an application view of the network or removing that underlying complexity. The other major methodology of SDN would be network virtualization. And with network virtualization, we're going to take that same complexity and faithfully replicate it back up into the application environment. And here we'll build our routers and our switches, our load balancers and our firewalls, but we're still riding on that same level of complexity. And now we have a virtual management layer for the network as well as a physical management layer for the network. So we're really just kicking that can of complexity down the street. With ACI, we take a different approach. We focus on the data center itself. And within that data center space, what we want to do is start by curing the disease or treating the complexity. So the first thing we want to do with ACI is to remove this complexity and abstract it out. By starting there with a clean slate in the data center, we can focus on what the application requires for the deployment of the network itself. What we want to be able to do is program in an automated fashion the way our network is deployed, and do that based on application requirements. What we don't want to do is try and build an over-intelligent network that's able to automatically analyze what applications are riding on top and be able to treat those applications with the correct security, quality of service, and SLAs. It's not really possible, and it's very cost prohibitive. A network can very easily detect if that's possibly an Oracle application running on top, but it won't be able to tell whether that Oracle application is development, test, or production. And those three different environments for the same application require very different needs from the network. So what we want to do is use the information that already exists in the business, the information that exists within development teams and within the application ownership teams, to be able to program down the network in a very cohesive fashion based on those application connectivity and policy requirements. The second major thing we want to do with application-centric infrastructure is to be able to have the network provide backup information to the application. And that information has to be relevant. When you look at providing information back up to application owners, up to developers, or maybe up to a network operations center, we want to make sure that we're not providing backup network jargon, latency, jitter, throughput, bandwidth, congestion. We want to provide backup relevant information based on that application. We want to be able to tell you how healthy that application is on the network and whether it's experiencing a problem that is network caused. So we want to take the application and use it to automatically program the network down. And we want to take the network and provide relevant information back up to the application owners. And this is the overall intent of what we do with ACI. It's not a redesign of the application or to build applications that are intelligent and network aware and rewrite them. It's to use how they already exist and use their policy and connectivity requirements to deploy the network. So I think the way in which we do this is much more interesting than the what we do. what we look at when we're looking at an application is that application as a whole. And an application doesn't exist in a silo. An application is not a single VM or physical server. An application is a group of tiers and the services those tiers consume. So when we look at ACI, we're looking at the tiers of an application. For instance, I can take a web tier, which is where I present that information up to my users. That web tier itself will most likely be utilizing another tier, typically an app tier in a 3-tier app model. And that app tier connects up to provide the information that's being presented to the users. From there, that app tier needs to be able to access data, and that data exists in a database tier. So we take that and connect it up to the database tier. Here we're drawing out a connectivity graph for how an application looks on the network. And the only thing really missing from how this connects is the policies that need to be in place for that connectivity. For instance, to connect to my web tier here, I need a set of policies that will provide the security and user experience that's required. Those policies might include things like layer 4 through 7 services, things like load balancers and firewalls. My web tier connecting to my app tier probably requires another set of load balancing, and maybe some permit deny rules and even quality of service rules. So I apply those policies on the connectivity between the web and app tier, and whatever policies are required between the next tier. So we draw out a connectivity graph with the required policies as a cohesive view of an application as a whole. From there, what we do is we group that into what we call an application profile. An application profile is a logical mapping of how an application is going to look, connect, and be treated on the network. We take that application profile, that logical template for how the application connects and works, and we deploy that down onto a stateless network infrastructure, including the layer 4 through 7 services that are required for that application's deployment. So we take this and programmatically instantiate it back down onto the hardware using a model that makes sense to the application owners and application developers, deployed automatically down onto the network. So this provides us policy-based connectivity in an application-centric fashion, and this is the heart and soul of what we do with ACI. Looking at the way in which this gets instantiated, when we take policy itself and draw out what policy comprises on the network, we look at things like quality of service. How does that network traffic need to be treated and prioritized on the network? We look at the SLA requirements for that application. If it's a production application, what are my uptime requirements? How robust does the network need to be underneath, and what are the redundancy requirements for that treatment? We look at things like security, firewall policy, permit, deny, and other things that we would be familiar with on a network space. All of these things tie in to that application profile and tie into the policy contracts that dictate how different tiers of the network are going to connect. This all wraps up into an application profile and then is deployed down onto that stateless hardware, as I stated before. If that application moves or migrates across the network for mobility purposes, we move the policy with the application. And if that application is decommissioned or possibly promoted through the development cycle, we'll remove the policy where it's unneeded, freeing up physical resources to be able to be used by other applications and other components of applications. That's what we're doing with application-centric infrastructure. I appreciate your time and hope it was useful. Please watch our other videos that go into some more of the details of the technical architecture below what we're doing with our model.